Hey, what is good everybody? Welcome back to the channel. In today's video, we're going to be setting up the renderer, which will be responsible for compiling our data on the CPU and shipping the data onto a GPU for further processing. And then once the processing has been completed by the GPU will then export that data onto our screen, which in this case will be on Metal View, which we set up in the previous video. So if you haven't watched the previous video, I highly suggest that you watch it in order for you to follow along in today's video, whereby we'll be setting up the renderer. And the renderer, of course, as you can see, is actually making use of the Metal View, which we coded in the previous video. So just to lay out the structure of this video, we're going to set up a few things in the following order. We're going to basically set up the Metal device, which essentially is simply the GPU that we're going to be using to render our graphics to the screen. And then we're going to set up a Metal command queue, and then we're going to set up the render path descriptor, and then from there we're going to set up the command encoder, and then from there we're going to set up the pipeline descriptor, and essentially we should have a renderer that is ready to render graphics onto the screen. So without wasting any time, let us set up our Metal device. So we're going to set up global variables here, and we're going to say Metal device, which is going to be of type Metal device, simply just that. And then we're going to set up another one, which we said is going to be our Metal command queue. So command queue. I think I forgot how to spell queue. I think I got it right though. Metal, let's see, Metal command, is it command? Yeah, command queue, like that. And then we're gonna basically need to initialize these in the constructor. So essentially we're just gonna say self dot Metal device is equals to I think it was just a function that just says Metal create system default device. Yeah, so this is essentially just the way that we select a GPU. It just tell Vulkan, hey, just select the default GPU that's on the system, right? And that's essentially it. However, you can initialize it in this manner. I'm just gonna be a little bit more safe with this and just say if let Metal device is equals to mtl let me see, mtl create, right? Is it mtl create system default device? And then we're just gonna do this, and then I'm just gonna take this, and then I'm gonna dump it in there, and I'm just gonna simply do it like this. This is essentially just the same thing. I'm just being more safer about it. And then after we have our GPU, so let me just annotate this and just say set up our GPU. Let's just say let Metal pick a GPU for us, all right, to use. All right, so once Metal has picked a GPU for us to use, we can then go ahead and set up our Metal command queue. So self.metal command queue is going to be equals to I believe we have to make use of our device that we selected, our GPU, and then we're gonna say Metal device dot make command queue, and essentially we have just initialized our Metal command queue. So now we can go down to this function down here called draw, and in the draw function we're gonna be drawing onto the screen, but we need some sort of a texture to draw onto. Now in this video we're not really gonna be setting up any textures. We're just simply gonna use a drawable, which I guess you can think about it as a texture. I'm not 100% correct or sure about that, which is already being provided by our Metal View. So how do we do that? So we're gonna call this a drawable. So I'm gonna just say drawable like that. I think I spelled it correctly. And then our drawable is essentially going to be equals to the view, which is essentially the MTK view. And then we're gonna say view dot what was it again? Current drawable? Yeah, I think it was current drawable. So we're gonna tell it that if we can find a drawable, then if we can't find a drawable, then return, right? because this function is responsible for drawing. So we need something to draw onto. So what I'm doing here with this, actually I needed to say guard.let with this guard, is that we're saying, hey, find a drawable, right? And if you can't find a drawable, then just simply return, because there's nothing to draw onto, so we can't necessarily draw anything. All right, but if something, or if you found a drawable, then okay, then read the next lines of code. All right, so after that, now that we have something to draw onto, we can finally create our command buffer. So we're gonna say let command buffer equals to metal command q dot make command buffer. Simple as that. Now what is a command buffer? Now essentially it's just a place where we're gonna be storing all our commands in, right? It's essentially a buffer for storing all of our commands in, right? I guess that's the most simplest description to give a command buffer. And then because we now have a drawable to draw onto, I guess we can just go ahead and write some command buffer commands, right? And just say command buffer.present, and then just pass in that drawable that we just basically created, and then we're gonna commit our commands and just say commit. Right now these two lines usually come at the bottom of everything, at the bottom of everything. Okay, so now that we have a command buffer, we're gonna need our render pass descriptor. And to create our render pass descriptor, I guess I'm just gonna create it right underneath the command buffer. So we're gonna say let render pass, I think I'm gonna make this one capital, render pass descriptor, okay, is equals to the view dot, was it view? I think it was view current render pass descriptor, yeah, like that. Okay, so now that we have our render pass descriptor, a render pass descriptor essentially just describes, let me just type this in, describes the resources that we will be making use of, right? For example, in this video, I think we're just gonna make use of the color attachment resources like this, and usually the first color attachment is what we're gonna be making use of, and we're gonna use that for the color, which you'll later see as we go forward. So yeah, so let's just define some parameters here. So render pass descriptor dot color attachments, the first one that we're gonna use is to basically clear the color. So essentially now we're gonna need to select a color to clear our screen with. So I think it was metal clear color, yeah, and then just red, blue, green, and alpha. So what color do we want our canvas to be? So I'm just gonna say black. Okay, I'm just gonna choose black here, and then the alpha, I guess we can just set that to 1, and then we're gonna go back again in there, render pass descriptor dot color attachments, the first one, and then I think what I need now is to set the load action. And if you don't know what the load action is, just do this load action, and then basically this is the action to be performed with this attachment at the beginning of a render pass. The default load action don't care unless specified by, yeah, you'll just read the documentation as to what this one is responsible for. And for us, I'm just gonna say clear here, and then I'm just going to say render pass descriptor again, the color attachment, and then this one, and then I'm just gonna say, instead of load, I'm gonna say store action, and then the store action for here is just gonna be store. And again, I'm not really gonna explain what that one is also responsible for, but you guys can Google that. Okay, yeah, so now that we have our render pass descriptor, we're gonna now need our let me see, render pass descriptor, we're gonna need our render encoder essentially now, yeah, command encoder, right? We're gonna call it our render encoder, so I'm just gonna say render encoder. Okay, and essentially this is gonna come from the command buffer, and then we're gonna just say command buffer dot make render was it make render command encoder? Yeah, and then we're gonna pass in the descriptor. It wants a metal pass descriptor, which we have just created. So we're just gonna say render pass descriptor like so, and that is it. So we now have our render encoder. And what does a render encoder do? So it will basically be used to encode our commands, which are stored on the command buffer. All right, so yeah, it's simply just to encode our commands that are stored on the command buffer. All right, yeah, that's essentially what the render encoder does. Yeah, that's the most simplest description I can basically give it. Apple documentations are not that great, by the way. They're not that descriptive. So yeah, so now that we have the render encoder, we can do a few things here. Now I'm gonna set up the viewport dimensions. So to do this, I believe we have to say render encoder.set viewport. Now why is it giving me an error though? Dot set viewport. This method is defined in metal render command encoder and may not be available in this context. Will I be wrong if I used it? I guess we'll find out. So let's see. I'm just gonna say the origin is 0 and then the width. Now the width is actually provided by the view. So I'm gonna say view dot drawable size. I think it was drawable size dot width like this, and then I'm gonna say the height is also provided by the view, and I'm just gonna say drawable size dot height, and then the z nearest should be 0 if I remember correctly, and then the z far should always be 1 if I remember correctly. You guys can always double check this on the internet, but I believe I am correct so far. All right, so next up is what else do we need? Why do we have an error though? Render encoder. There we go. That's why I was getting an error here. It's because we didn't have an equal sign over here. So I'm gonna just save this and hopefully it'll get rid of that error fuzz. And then let me see what I did here. Let render encoder command buffer make render command encoder descriptor and the pass descriptor. What is the error? Okay, yeah, I actually just need to put an exclamation mark here. I think this will silence the error. Yeah, let's just see. Yeah, SwiftUI, man. Swift can actually get to you sometimes. All right, so let's carry on. So now that we've set our viewport dimensions, we can then go ahead and then create our render pipeline. So to create our render pipeline, essentially we need to go all the way up here and then create another variable, and this one we're gonna call it, what do we want to call it? I don't know, let's just say pipeline descriptor like so. All right, and then this one is going to be mtl render pipeline state. So now we're just simply going to be initializing the pipeline state. So all we got to do now is just come down to our constructor here and then create our pipeline. So yeah, so what we're going to essentially do is just say let, we're going to call this a pipeline descriptor because it is a pipeline descriptor. Just describes what our pipeline is going to be having. So it's going to be metal. Is it metal? Yeah, it's going to be metal. Render pass descriptor, if I'm not mistaken. Nope, not a render pass descriptor. It's supposed to be render pipeline descriptor. And then from there, we're going to need a library. And then I'm going to say library is equals to self.metalDevice.make default library, and this essentially just simply searches for the shaded shaders, right? It just simply searches for the shaders that we want to make use of. In this case, it will be the vertex shaders, vertex shader, and the fragment shader. All right, and then we're gonna let it know the names of those fragment shaders and vertex shaders. So we're just gonna say I'm just gonna say pipeline descriptor dot vertex function is then equals to library, and I think it was library dot make function, and then the name that we're passing in here is the name of the vertex shader that we're gonna be using, right, in our pipeline. So essentially this is just binding, basically binds the vertex shader, and I'm just gonna copy this line, and then we're just gonna basically bind the fragment shader, and then we're gonna call the fragment shader, and then this simply just binds the fragment shader. Now if you're coming from OpenGL and Vulkan, you know that it's quite a process to bind your shaders and all of that and compile them. Especially in Vulkan, we have to use SwiftUI and all these other things, whereby in Metal it's just as clean and simple as this. Like we've literally just binded our shaders and there's nothing more to it. So then the last thing that we want to do is basically just go into our color attachment and then simply just set the pixel format to .rgba 8 and I think this is the default one that's in our Metal view. And yeah, so just make sure you have this in your Metal view. You don't really have to set it up because I believe the default value is RGB8 but yeah, if you want to be explicit like I am, then do add it here in your Metal view. Yeah, just make sure that they are the same though, because you will get an error when you try to run your shaders, when you try to run your renderer down the line. So now all you need to do now is basically use our pipeline descriptor. So use our pipeline descriptor for our render pipeline. So to do that, we just need a do catch because it can throw an error. And then if it does throw an error, all we gotta do is just basically just say cannot create render pipeline like this. And then basically to create our pipeline, all we have to do is say try self.pipeline state, and then just set that to self.metal-device.make render pipeline state, and just pass in our pipeline descriptor that we just created over here into here. And then I believe that is it right there for our pipeline. So all we got to do now is just come down here and basically set that up so that our encoder knows about it. So set render pipeline state to pipeline state. Done. All right, so this essentially is just binding our render pipeline and our shaders and everything. Pipeline, render pipeline. I guess I like the word pipe. Has a nice ring to it. Yeah. So yeah, that's essentially it, I believe. Oh yeah, and then finally all we gotta do is just encode. So let's just say encoding like this, and then boom, we are done. If we try and run this, we're gonna get an error. That's because we haven't defined our shaders. So I'm gonna do that real quick. So I'm just gonna create a new metal file and we're gonna call it shaders. And then we're just gonna click OK, and then we're gonna set up our vertex shader, and then it's gonna return a float 4, and then we're gonna call that vertex shader. And then the vertex shader is just gonna return a float 4, and then it's just gonna be a default value there. And then the fragment shader is also just gonna return a float 4, which is gonna be our color. So fragment shader like so, and then just return float 4 like so. And I think it should work. I'm not 100% sure, but these names, they need to be the same names that you write here. Okay, so yeah, they are the same, so therefore we are good to go. And then if I go to my content view, I should be seeing something. Yay, we see red. And the reason why we're seeing red is because we're clearing the color here, right? And I said this was supposed to be black. I don't know what happened. So yeah, so this should be black now, and voila. So we now have set up our renderer, and it's basically clearing to the screen. And then in the next video, we will basically be rendering our very first triangle. So yeah, that is it for this video, guys. It's been a long one, but we finally have our renderer set up, and we can finally start talking shaders and getting into the nitty-gritty of the world of shaders. So if you enjoyed this video, hit that subscribe button, and I'll see you guys on the next one. Cheers.